Jupiter's Great Red Spot is not what you think. Almost everyone believes it's a fixed, permanent landmark, a giant eye that has always stared back at us from the clouds and always will. That's wrong. This is not a stable feature. It is a storm. A single, raging storm that has been spinning for at least 190 years, maybe as long as 350. And right now, it is de-eying. It's shrinking. It's changing color. It's somehow growing taller as it gets smaller, and it's drifting faster than ever before. Scientists don't know exactly how old it is. They don't know why it's red. They don't even know why it never burned out like every storm on Earth eventually does. So, let's dive in. This is the story of the most iconic vortex in the solar system, quietly transforming right above our heads, and every answer we uncover only opens up a bigger mystery. Let's start with the scale, because that's always the first thing that breaks people's brains about Jupiter. The Great Red Spot is wide enough to swallow the entire planet Earth whole, with room left over. Now let's talk about age. Astronomers have kept a continuous, year-by-year record of this storm since 1878. But the very first confirmed sighting goes back even further, to 1831. That alone makes it at least 190 years old, a single storm that has outlasted the entire history of powered flight, the automobile, and most nations on Earth today. But here's where it gets stranger. There's an older record, one astronomers still argue about. In 1665, the astronomer Giovanni Cassini spotted something he called the permanent spot and tracked it for decades until it vanished from the records in 1713. Some credit an even earlier sighting to Robert Hooke. Was that the same storm we see today, quietly hiding or fading for over a century before returning? Nobody actually knows. It's entirely possible this storm has been raging for 350 years. Either way, we're talking about a storm that may have been spinning long before the United States existed. And that raises an obvious question. On Earth, hurricanes are lucky to survive a few weeks before they die out. So how does a storm on Jupiter last for centuries without ever running out of energy? The answer starts with something Jupiter simply doesn't have. On Earth, storms die because they eventually hit land. Friction from the ground slows them down, cuts off their energy supply, and within days, the whole system falls apart. Jupiter doesn't have that problem because Jupiter doesn't have land. There's no surface anywhere on this planet, just atmosphere all the way down. It's a bottomless abyss with nothing to create friction and nothing to slow a storm like this one down. So the Great Red Spot just keeps spinning. It's what's known as an anticyclone, a high-pressure vortex rotating counterclockwise, and it's held firmly in place by two jet streams, one to the north and one to the south, both blasting in opposite directions. Picture a ball of dough rolled between the palms of your hands. That's essentially what's happening here, except the palms are made of wind, moving at hundreds of kilometers per hour. Inside the storm, the center stays relatively calm, but the outer winds are ferocious, blasting between 430 and 680 kilometers per hour. And it turns out this storm doesn't just spin forever on its own. It actually feeds. Like a cosmic cookie monster, the Great Red Spot gobbles up smaller storms that wander too close, absorbing their energy to keep itself alive. So if it's still feeding, still spinning, still protected from friction, why has it been quietly shrinking for the last 150 years? Here's the reveal. The one thing everyone assumes is permanent and unchanging has actually been disappearing for over a century, right in front of us. Back in the late 1800s, the Great Red Spot measured around 41,000 kilometers across, big enough to swallow 3 entire Earths, with room to spare. By the time Voyager flew past in 1979, it had already shrunk down to about 23,300 kilometers. By 1995, it was down to roughly 21,000 kilometers. By 2009, around 17,900 kilometers. And today, the storm measures approximately 16,500 kilometers across, the smallest it has ever been recorded. Let that sink in for a second. This storm used to be big enough to fit 3 planet Earths inside it. Now it can barely contain one. And the shrinking hasn't been slow and steady the whole time. In 2012, something changed. The rate of shrinkage suddenly accelerated, with astronomers watching the storm's width shrink by close to 930 kilometers every single year. On top of that, its shape has been changing too, morphing from a long, stretched-out oval into something closer to a circle. Here's the part that should sound familiar by now. Nobody actually knows why. We can watch the numbers fall year after year. We can chart the shape shifting. But the underlying cause behind the shrinking remains a mystery. And as strange as that is, it's not even the strangest thing happening to this storm. When scientists first noticed the Great Red Spot shrinking, they expected one obvious result. Think of an ice skater pulling her arms in tight. She doesn't slow down, she spins faster. Scientists assumed the same thing would happen here, that a shrinking storm would spin up into something more violent and compact. That's not what happened. Instead of speeding up, the storm started stretching upward. Picture a lump of clay on a potter's wheel. As the wheel spins, pushing the base inward doesn't just make it smaller, it forces the clay to rise, stretching into a taller, thinner shape. That's essentially what's happening to the Great Red Spot. As its width shrinks, its height is increasing, and this seems to be connected to another strange shift. Since around 2014, the storm's color has been deepening, turning a much more intense orange. One theory is that as the storm stretches upward, its chemical compounds get lifted higher into the atmosphere, closer to the sun's ultraviolet radiation, which reacts with them and darkens the color even further. Which brings us back to a question nobody has fully answered. Why is the Great Red Spot red in the first place? We still don't really know. What we do know is that the storm isn't just shrinking, it's transforming. To really understand what is happening to this storm, scientists needed to stop staring at the surface and start looking underneath it. That's where NASA's Juno spacecraft comes in. Launched in 2011 and arriving at Jupiter in 2016, Juno has been swooping within a few thousand kilometers of the cloud tops every 53 days, carrying instruments built specifically to peer beneath the clouds. Juno does this in 3 ways. It measures tiny shifts in Jupiter's gravity to sense mass hidden deep below. It tracks the planet's magnetic field to map flows in the deep, electrically charged layers. And it uses microwave light, which can travel straight through the clouds like an X-ray. In 2019, Juno flew directly over the Great Red Spot at more than 200,000 kilometers per hour. Meanwhile, NASA's Deep Space Network was tracking the spacecraft's velocity from millions of kilometers away, and it detected changes as small as 0.01 millimeters per second, tiny gravitational tugs caused by the storm itself. From that data, scientists calculated that the Great Red Spot's roots extend somewhere between 300 and 500 kilometers beneath the clouds. For comparison, that's deeper than the International Space Station orbits above Earth. But here's the twist. Compared to its width of over 12,000 kilometers, that depth is surprisingly shallow. The storm is essentially a giant pancake, roughly 40 times wider than it is deep, floating in an atmosphere with no bottom at all. And just beneath it, Juno found something nobody expected. In the visible cloud layer, everything behaved exactly the way scientists expected. Through microwave light, the pale zones appeared dark, showing ammonia gas, while the darker belts appeared bright, showing an absence of ammonia. Simple and predictable. Then Juno looked about 45 to 80 kilometers deeper, and everything flipped. The belts, which had been bright, turned dark. The zones, which had been dark, turned bright. A complete reversal, hiding just beneath the clouds everyone had been studying for centuries. Scientists named this hidden boundary the Jovic line. It's similar to something we have right here on Earth, the thermocline in our oceans, the layer where warm surface water gives way to cold, dense water below. Except this time, it's happening inside a planet made of gas and liquid. Interestingly, this isn't even a new idea. Back in 1971, science fiction author Arthur C. Clarke imagined a similar hidden layer deep inside Jupiter's atmosphere, decades before anyone actually found one. So what's causing the flip? One theory points to giant circulation cells, roughly 8 per hemisphere, acting like conveyor belts that shuffle ammonia up and down. Another theory blames massive storms that create ammonia water hailstones, nicknamed mushballs, which fall deep into the planet before evaporating and enriching the atmosphere far below. Either way, something enormous is stirring beneath the clouds, and every new layer we uncover only raises more questions. Put all of this together and you get a storm that's shrinking, deepening in color, stretching taller, and now drifting westward faster than ever recorded. That faster drift is concerning because it could push the storm into regions with weaker winds or disrupt the very energy supply that's kept it alive for centuries. So what happens next? Nobody agrees. Some scientists think it will simply stabilize at a smaller size. Others think it will keep shrinking until it becomes just another temporary red oval, no different from the smaller storms it once fed on. And some think it could break apart entirely. There is also the diet theory. Simulations show that feeding on smaller storms is part of what keeps the Great Red Spot large and strong. If that supply of smaller storms ever dries up, the giant could effectively starve. Researchers studying this storm have said the next 5 to 10 years could bring rapid, dramatic changes. As one scientist put it, the Great Red Spot may end up not being so great after all. We've been watching this storm for centuries, but only now are we realizing how little we actually understood about it. It's not permanent. It's not stable. It's alive, shifting, and quite possibly dying right in front of us. We still don't know exactly how old it is. We still don't know why it's red. We still don't know if it will vanish within our lifetime or the next generations. What we do know is that we may be witnessing the slow transformation or the ending of one of the greatest landmarks in the solar system. And that's what makes the Great Red Spot so captivating. It's not a fixed point in the sky. It's a mystery still unfolding right above our heads.